The slowest tank in the world. How the super-heavy T28, weighing 100 tons, became the laughingstock of the United States Army. Imagine a tank that moves slower than a pedestrian. Not hit, not broken, but completely functional and fully fueled. Its designers simply got so carried away with armor and armament that they completely forgot about the engine. The result was so ridiculous that the American Army at first did not know what to do with this monster, then successfully lost it, and then searched for it for almost 30 years. And this is not a joke, but the real story of the T28 Super Heavy tank, which is also known as the T95. A 100-ton machine with impenetrable armor, a powerful gun, and a completely shameful speed of 13 kilometers per hour became one of the strangest projects in the history of American tank building. And it all started in 1943, when Allied commanders were planning a landing in Western Europe. Staff officers understood perfectly well that after a successful landing, the troops would have to break deep into the continent, and a serious obstacle would stand in their way. This was the famous Siegfried Line, which the Germans called the West Wall. This grandiose system of fortifications stretched from the Swiss border to the North Sea itself. Thousands of concrete bunkers, anti-tank obstacles, minefields, and artillery positions formed a practically insurmountable defense line. Conventional tanks of that time could get bogged down in these fortifications for a long time while suffering monstrous losses. It was then that a man with an ambitious plan appeared in the Ordnance Department. General Gladian Barnes proposed to create a fundamentally new machine, specially designed to break through fortified positions. His project was called an assault tank, and the requirements for it sounded fantastic even by the standards of that time. Barnes wanted to install a high-power 105mm anti-aircraft gun on the machine, capable of destroying concrete bunkers with direct fire. The frontal armor was supposed to reach a thickness of 200 to 250 millimeters, which made the tank practically invulnerable to any existing anti-tank weapon. And as a power plant, the general suggested using an electric transmission developed for the T1 series of heavy tanks. But the boldest point of the plan was the timing. Barnes insisted on producing 25 of these machines within 8 to 12 months, so that they would arrive in time for the start of hostilities in Europe. The military leadership listened to the presentation of the general and grabbed their heads. It was practically impossible to create a super-heavy tank from scratch in such a short time. In addition, the electric transmission that Barnes insisted on was an extremely temperamental and unreliable system, completely unsuitable for combat conditions. In March 1944, the Army Ground Forces Command issued its verdict. Instead of 25 machines, the Army agreed to order only 3 prototypes for testing. At the same time, the ill-fated electric transmission was required to be replaced by a conventional mechanical one. General Barnes was furious with this decision and wrote an angry letter to officials, demanding to review the number of machines ordered. After long negotiations, the parties reached a compromise, and the number of tanks was increased to 5 units. The new machine received the official designation Heavy Tank T28. It would seem that the project finally moved off the ground, but the American military did not yet suspect what kind of adventure they had gotten themselves into. Finding a plant capable of producing such monsters turned out to be a task no less difficult than designing the tank itself. The majority of enterprises simply did not have the equipment to work with such dimensions and weights. Only in July 1944 did Pacific Car and Foundry agree to take on this order. However, even this plant could not manufacture the massive cast parts of the front hull, and they had to be ordered separately from General Steel Castings. While engineers agreed on drawings and argued about the characteristics of the future machine, the war in Europe went its way. The Allies landed in Normandy, liberated Paris, and relentlessly advanced to the German border. And the tank that was supposed to crush the Siegfried Line still existed only on paper. The Super Heavy Tank project was plagued with naming problems from the very beginning, and this confusion persists to this day. Many military equipment fans, familiar with this machine from computer games, are sure that the T28 and T95 are different tanks. Someone believes that the version with 2 track belts is an early modification, and with 4 belts is a late one. Others believe that we are talking about a tank destroyer. In fact, all this is the same vehicle. The American military simply managed to rename it 3 times in less than 2 years. Initially, the machine was called Heavy Tank T28, and under this designation it passed through documents since March 1944. But in February 1945, the chief of the Ordnance Department suddenly raised the issue of classification. He rightly noted that this machine does not have a rotating turret, which means formally it cannot be considered a tank. After a short deliberation, officials agreed with this argument and a month later approved a new name, 105mm self-propelled artillery piece T95. It would seem that the issue is resolved, however. A year later, it turned out that this designation was also not suitable. Self-propelled guns of that time were light and mobile machines, and the armored giant weighing under 100 tons did not fit into this category at all. In June 1946, the tank was assigned its final name, Super Heavy Tank T28. In fact, the machine received its own unique category because it simply did not fit into any existing classification. While bureaucrats argued about names, engineers tried to bring the design to mind. And here, too, complete chaos reigned. Requirements for the machine changed constantly, and sometimes in diametrically opposite directions. Initially, the frontal armor was supposed to be 250 millimeters. Then someone decided that this was too much, and the thickness was reduced to 200 millimeters for the sake of weight saving. But then the pendulum swung back, and in the final version, the frontal plate reached 305 millimeters. No serial tank of that time had such a thickness. For comparison, the famous German Tiger carried only 100 millimeters of armor on its forehead, that is 3 times less. Metamorphoses also occurred with the armament. Originally, it was planned to install a 105mm anti-aircraft gun T5, but then it was replaced by a lightweight version, T5E1. This gun possessed excellent characteristics and could destroy concrete fortifications from a long distance. The development of the gun mount was entrusted to Chevrolet, and its engineers had to break their heads over how to place such a powerful weapon in a low hull without a turret. As a result, the gun received very modest guidance angles, only 10 degrees horizontally and from -5 to +19 degrees vertically. In fact, for aiming, it was necessary to turn the whole tank, which, given its turtle-like speed, turned into a separate adventure. In August 1944, the fabrication of a wooden mock-up began so that engineers could evaluate the layout and identify potential problems. Work on the coordination of drawings between the Ordnance Department and the Pacific Car Plant dragged on for long months. Every detail required approval. Every change entailed a chain of alterations in adjacent components. Especially much trouble was caused by the massive cast part of the front hull. Its manufacture at the General Steel Castings plant began only at the end of 1944, and the first finished casting arrived at the assembly plant only in June 1945. The assembly of the first hull was completed in August of the same year. About a year and a half had passed since the approval of the project, and by wartime standards, this was a good result for such a complex machine. But the war did not wait for the American engineers. By the time the first hull of the Super Heavy tank was ready, combat operations in Europe had already ended. Germany surrendered in May, and the fearsome Siegfried Line, for the breakthrough of which this monster was created, was long left behind by the advancing Allied forces. The tank was late for its own war, and a few weeks after the completion of the assembly of the first hull, an event occurred that put an end to the entire mass production program. In August 1945, Japan announced its surrender, and the Second World War ended completely. The urgent need for new armored vehicles disappeared overnight. The military leadership immediately revised all current orders, and the number of super heavy tanks was reduced from 5 units to 2, which were already in production. The remaining 3 machines were never built. The first fully assembled copy went to the Aberdeen Proving Ground in December 1945, and the second arrived there in January of the following year. When the military first saw the finished machine live, many of them could not believe their eyes. This armored Leviathan struck the imagination with its dimensions and made a completely overwhelming impression. The hull length was more than 11 meters, and the width exceeded 4.5 meters. But the main shock was the mass of the machine, which reached 86 tons in the basic configuration and exceeded 95 tons with external track modules installed. It was these additional track modules that became one of the most unusual features of the design. Engineers understood perfectly well that a machine of such monstrous mass would simply press through any soil with its narrow tracks and get tightly stuck in the very first puddle. To reduce ground pressure, they developed an original solution: removable external track blocks that were attached to the sides of the hull. Each such block represented a full-fledged track propulsion unit with its own rollers and drive wheels. As a result, the tank received 4 track belts instead of the usual 2, which allowed it to move more or less confidently on soft ground. However, a high price had to be paid for this solution. The width of the machine with external modules installed made its transportation by rail or across standard bridges impossible. Therefore, the designers provided for the possibility of dismantling the side blocks for transportation. In theory, everything looked logical, but in practice, the procedure for removing or installing external tracks took from 2 to 4 hours of hard work by the crew, and this was subject to the availability of special equipment and a prepared site. After dismantling, the blocks could be towed behind the tank on a rigid hitch, which was a rather comical sight. A huge armored vehicle drags 2 track modules behind it like trailers. The tank's armor really had no analogs among serial vehicles of that time. The upper frontal plate reached 305 millimeters in thickness, which made it practically impenetrable for any existing anti-tank gun. The gun mantlet was slightly thinner and stood at 292 millimeters. The side plates in the front of the hull had a thickness of 216 millimeters, and the lower frontal part was protected by armor of 140 millimeters. The upper part of the hull sides carried 64 millimeters of armor at an angle of almost 60 degrees, which significantly increased shell resistance due to the slope. Even the external track modules received their own armored protection: 102 millimeters on the sides and 76 millimeters in front. For comparison, the frontal armor of the German Tiger was only 100 millimeters. That is, the external tracks of the American Monster were protected better than the forehead of one of the most fearsome tanks in Germany. The vehicle's armament consisted of a 105 millimeter gun T28 with excellent ballistics. This gun accelerated an armor-piercing projectile to a speed of almost 1,000 meters per second and could hit any fortifications at a direct fire distance. The ammunition load consisted of 28 rounds placed in racks inside the fighting compartment. The only additional weapon was a 12.7 millimeter machine gun on the commander's cupola, intended for fighting infantry and air targets. The crew of the vehicle consisted of 4 people: a driver, a commander, a gunner, and a loader. The conditions of their work inside the cramped fighting compartment could hardly be called comfortable. The absence of a rotating turret meant that the entire crew was in a single space without the possibility of all-round visibility. To aim at targets outside the modest horizontal guidance sector, it was necessary to deploy the entire hull. And this is where the most interesting part began. All this armored power was driven by a Ford gasoline engine with a capacity of only 500 horsepower. Exactly the same motor was installed on the M26 Pershing medium tank, which weighed 3 times less. The specific power of the super heavy tank was about 5 horsepower per ton, which was catastrophically small for a vehicle of this class. The result was predictable. The maximum speed did not exceed 13 kilometers per hour on the highway. And on rough terrain, it fell to completely indecent values. An infantryman with a fast pace could overtake this steel giant without much effort. The cruising range with a full fuel tank capacity of about 1,500 liters was approximately 160 kilometers, which was also a very modest figure. Testing at the Aberdeen Proving Ground began in January 1946 and immediately revealed the main problem of the vehicle. The power plant worked at the limit of its capabilities, constantly overheated, and required frequent stops for cooling. Mechanics recorded one minor failure after another, although serious breakdowns were avoided due to the fact that most components and assemblies were borrowed from already proven vehicles. The transmission, suspension, and chassis as a whole coped with their tasks, but the engine frankly did not pull the load placed on it. During the entire testing period, the tank traveled 870 kilometers, and, given its turtle speed, it took long months to accumulate such mileage. Every trip to the track turned into a test of patience for the crew and observers. The machine crawled along the range with a straining roar of the engine, leaving deep ruts behind even on relatively hard ground. Turns required a huge space and took an unforgivably long time. Any more or less steep climb became a serious obstacle, which the tank overcame on the verge of stopping the engine. On the other hand, firing tests brought completely different results. The gun showed excellent accuracy and destructive power, fully meeting the expectations of the designers. Armor-piercing shells confidently penetrated simulations of concrete fortifications and armor plates at design distances. The commission particularly noted the high initial velocity of the projectile and the flat trajectory, which allowed accurate fire at long distances. In the final report, it was recommended to use this gun on future armored vehicles, which was subsequently done. No less impressive were the results of the armor resistance check. At the range, fire was conducted at the tank from captured German 88mm guns, which had struck terror into Allied troops throughout the war. These guns, installed on Tigers and anti-tank self-propelled guns, were considered among the best in the world and could hit almost any Allied armored vehicles. But the frontal armor of the American Giant withstood all hits without critical damage. The shells left dents and gouges. However, none of them could pierce the 300mm barrier. This was a convincing demonstration that the concept of a super-heavy assault tank had a right to exist, at least in terms of protection. The second prototype, meanwhile, went on a long journey. First, the machine was delivered to Fort Knox, and then transferred to a testing site in Yuma, Arizona. The desert climate of this region was ideally suited for testing equipment in extreme temperature conditions. In addition, there were special ranges for testing pontoon bridging equipment. Military engineers wanted to find out whether existing floating bridges were capable of withstanding the weight of the 100-ton monster. The results of these experiments were disappointing. Most of the standard crossing equipment was simply not designed for such a mass, which created serious problems for the potential combat use of the vehicle. But in 1947, a disaster befell the second prototype. During another outing, the engine caught fire, and the fire quickly engulfed the engine compartment. The crew managed to leave the vehicle, but it was not possible to extinguish the flame. The fire completely destroyed the power plant and damaged the internal systems of the tank so severely that restoration was recognized as impractical. The commission decided to write off the machine and send it for scrapping. Thus, the program lost half of its precious prototypes, and now all hope was placed on the only surviving copy in Aberdeen. In October of the same year, the testing commission presented the final report on the program. The conclusions of the document sounded disappointing. The mobility and reliability of the vehicle were recognized as unsatisfactory. The tank turned into something too slow, too heavy, and too temperamental for practical combat use. The only bright spot was the high evaluation of the gun, which indeed showed outstanding characteristics. But one good gun was not enough to save the entire project. As if by irony of fate, in the same month when the commission was signing the sentence for the Super Heavy tank, the first copy of a completely new vehicle arrived at the Aberdeen Proving Ground. This was the T29 heavy tank, embodying a fundamentally different approach to design. Instead of a clumsy, turretless structure, engineers created a classic tank with a full-fledged, rotating turret. At the same time, it carried the same 105mm gun as its Super Heavy counterpart. Of course, the armor was significantly weaker, but the mobility and practicality could not be compared. The choice of the military was obvious, and the future clearly belonged to the new competitor. In October 1947, the Super Heavy tank program was officially closed, but the surviving prototype was not sent for melting down. Its huge mass came in handy for conducting load tests on bridges and road surfaces. The former contender for the title of Fort Crusher lived out its days in the role of a banal counterweight. After the closure of the program, the only surviving prototype remained on the territory of the Aberdeen Proving Ground, where it continued to be used as a heavy load for various engineering experiments. The giant machine regularly pressed down with its mass on test specimens of bridges and road surfaces, bringing at least some benefit to the Army. But gradually, interest in these works faded, funding was reduced, and the strange, turretless tank began to be forgotten. At some point in the early 50s, the machine simply disappeared from the field of view of military officials. No one knew exactly where it went and what happened to it. Confusion reigned in the documents, responsible officers replaced each other, and the paper trail was lost in the bureaucratic chaos of the post-war reorganization of the Army. The most amazing thing was that we were not talking about some minor detail or a box of spare parts. An armored vehicle weighing almost 100 tons and more than 11 meters long had disappeared. It would seem physically impossible to lose such a monster, but the American Army managed to do exactly that. When in subsequent years historians and museum workers tried to find out the fate of the unique prototype, they invariably hit a blank wall. Official archives contained no information on whether the tank was recycled or moved somewhere. Most experts came to a logical, as it seemed to them, conclusion. The machine had long been cut up for scrap metal, and it was useless to look for it. On this, the story of the Super Heavy tank, it seemed, ended forever. Almost 30 years passed. By the mid-70s, only narrow specialists in armored vehicles and military history enthusiasts remembered this unusual project. And so in 1974, the Army Reserve magazine published an intriguing material. The editors placed an old black-and-white photograph of a mysterious turretless armored vehicle on its pages and invited readers to try to identify it. This was a kind of quiz for military enthusiasts, designed to test their erudition in the field of equipment. The editors expected to receive several letters with correct answers and close the topic at that. But one of the incoming letters contained much more than just the name of the machine in the photograph. The author of the message turned out to be a captain of the Army Reserve, serving at the Fort Belvoir base in the state of Virginia. He not only unerringly determined that the picture showed a T28 Super Heavy tank, but also reported completely sensational news. According to the captain, this very machine is right now on the territory of his base. The tank is standing on a range for testing night vision devices, densely overgrown with bushes and covered with a camouflage net. All these years, the armored giant was simply sticking out in the middle of a training field, and it never occurred to anyone to wonder what kind of strange piece of iron it was. The magazine editors contacted the Patton Museum at Fort Knox, which specialized in the preservation of historical armored vehicles. The first reaction of the museum staff was disbelief. They were absolutely sure that the only prototype had been destroyed long ago, and the captain's message seemed to them a bad joke or an error. However, the author of the letter insisted on his own and offered to provide proof. When photographs of the bush-overgrown tank reached the experts, doubts vanished completely. The characteristic low silhouette, 4 track belts, massive gun mount in the frontal part of the hull. This really was the same lost prototype that everyone considered destroyed. The news of the find had the effect of an exploding bomb among historians and collectors of military equipment. The unique machine, the only one of its kind, spent almost 3 decades under the open sky on a forgotten range, and at the same time managed to survive well enough for restoration. The Patton Museum immediately organized an expedition to evacuate the tank. The process of extracting the armored giant from the thickets and transporting it to Fort Knox became a separate adventure, given the dimensions and weight of the vehicle. But in the end, the operation was a success, and the Super Heavy tank took a place of honor in the museum exhibition. There it stood until 2011, when the collection of the Patton Museum began to be moved to a new site. The tank was transported to Fort Benning, where it remains to this day in the training center of the armored forces. Visitors can see this unusual monster with their own eyes. The heaviest American tank of the Second World War, which was late for its own war, became a laughingstock because of its turtle speed, was lost by its own army for 30 years, and then miraculously found thanks to an accidental publication in a magazine. Such is the amazing fate of the T28 Super Heavy tank.